Hey everyone. We're going to go over the notes for dilations on a coordinate plane. All right, so let's go ahead and get started into this. So if given a scale factor, and we talked about this before, but if given a scale factor, we are going to multiply. Okay, so go ahead and make a note here to multiply. Okay, and to dilate a figure on a coordinate plane, we're going to multiply the x and y values of each ordered pair by the given scale factor. Okay, now if the scale factor is more than 1, we know that the picture should get larger or the image should get larger. So we're going to say if the scale factor is more than 1, this will reduce in a grow or an enlargement. Okay, if the scale factor is less than 1, not negative, but less than 1, so a fraction less than 1, it will shrink or reduce. Okay, so that is what we're going to do when we have scale factor. Remember, we're going to multiply, and then we should know that if we're looking at an image and it tells me scale factor is more than 1, it will grow, and if scale factor is less than 1, it will shrink. Now, in reverse, if we need to find the scale factor, we need to know that we have to divide. Okay, and to set this up, we are going to look at the new figure and or the image and set up a ratio of corresponding sides to the original. So we would call this new over original, new over old, or image over pre-image. This is very important. It doesn't work the other way around, original over new. It is always new over original. Okay, so let's go ahead and look at this first example. We have to dilate the rectangle by a scale factor of 1/3. So we know that because the scale factor is 1/3, this image will shrink. Okay, so the pre-image is already given to us, and the ordered pairs are as follow. So I have A, which is 6 comma negative 6 comma 3. I have B, which is 6 comma 3. I have C, which is 6 comma negative 3. And I have D, which is negative 6 comma negative 3. Okay, so now we're going to apply the scale factor of 1/3. So what that looks like is, and I'm going to write over here to the side for a second. What that's going to look like is 6. So if I look at the new A, and I'm going to draw or use a different color, my new A over here with that prime notation, this right here is called prime notation. It looks like an apostrophe, but that lets me know that it's new. But what we're going to do is we're going to multiply negative 6 by 1/3. Okay, that is the same thing as saying 6 over 1 times negative 1 over 3. That becomes, and let's give us some room here, negative 6 over 3, which reduces to negative 2. Okay, so for our new A, the first point is negative 2. Okay, then we do the same thing, and this is my x value, by the way. Now for my y value, I need to multiply 3 by 1/3. Okay, 3 over 1 times 1 over 3 is equal to 3 over 3, which equals 1. So then my y value, or my y coordinate, now becomes 1. So my new ordered pair is negative 2 comma 1. So what we did there is we applied the scale factor to my x value and my y value to get a new coordinate. So I'm going to follow that pattern all the way down. And if you notice, all of these are 6 and 3. So I just need to pay attention to my sign here. But to go through those steps, 6 times 1/3 would be a positive 2. 3 times 1/3 would be a positive 1. Okay, that would be my B prime or my new B. 6 times 1/3 would be 2. And then negative 3 times 1/3 would be negative 1. And we follow this pattern all the way down, right? So -6 times 1/3 would be -2, and -3 times 1/3 would be -1. So now I have all of my new coordinates, and we're going to graph these points on the graph. So our first one is -2, 1, which will be my A. Okay, there's my A. And then my B would be 2, 1. My C would be 2, -1. And my D would be -2, -1. And I'm going to put the little prime notations on each one of those. So if I connect the dots, I should be able to see my smaller rectangle in there. And as we can see, it's considerably smaller, right? So we notice that this scale factor did indeed result in a reduction. So now how can we express this algebraically? And by algebraically, what we're asking is, how can we say what happened to both values of x and y for my original? So if this is my original, x comma y, so I'm going to call this old or original, how do I get to my new? What happened? Well, we multiplied my x value by 1/3, and we multiplied my y value by 1/3. And this is how we express this algebraically. Notice that it's 1/3 multiplied by x and 1/3 multiplied by y. They don't equal each other. This is saying that if I apply scale factor to every single x, I will get a value. If I apply 1/3 to every single y, I will get my new value as well. So that is what we're talking about when we say algebraic representations. Okay? Um, be sure if you didn't catch that, make sure you pause, rewind it, watch it again if you need to. All right. So number 2, it asks us, compare the ratios of the corresponding sides. What do you notice? Well, if I look at BC, right, we can see that this is 1, 2, 3, 4, 5, 6. So that's 6. Okay, so that's my original. Remember, we have new over original, right? So on the bottom, we have 6. And then on my longer side is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I have um, 12 here. Okay, now we need to figure out our new lengths, right? So our new side over here for BC would be 1, 2. So that's, let me erase this real quick. This would be 2. And the other side of my AB that corresponds would be 1, 2, 3, 4. All right, let me explain what I just did because I don't think I said that very clearly. What I did was I looked at our corresponding sides here. So this would be segment BC, and this would be segment AB, right? What we're looking at is what happened from our original to our new. Okay, we notice that it went from 6 to 2 and 12 to 4. What we notice here is that if I were to reduce both of them, they both would reduce to 1 over 3, which is our scale factor. And also, this lets us know that the corresponding sides are proportional. Okay, they're proportional, they have the same scale factor, and that also lets you know that they're similar figures too, as something that we did prior. Okay, the next part. Did the dilation change or preserve the orientation of the figure or of the vertices? So when we're talking about orientation, we're asking, did this figure rotate or flip? And when we look at this picture, it didn't rotate or flip. All it did was shrink. It changed size. And so when we talk about dilations, they don't change orientation, they preserve. Okay, so they preserve orientation. And the only thing that they do is affect the size. Okay, so they do not preserve congruency, but that's a whole nother question. Okay, so I'm sure you might have some questions or you might not have got everything that you saw there, but just remember that you can pause and rewind and go back to where you were in the video. Okay, so we're going to continue on though and look at number 4. So number 4 says to dilate the figure by a scale factor of 2. Well, when we do that, we know that this scale factor 2 is going to result in an enlargement, or the shape is going to get bigger. So our original E is at negative 4 comma 2. Remember, x goes first. So E is at negative 4 comma 2. And I'm just going to go alphabetically. So E, F, G, H. So F is at 4 comma 2. G is at 3 comma negative 1. And H is at negative 3 comma negative 1. Okay, so if I'm applying scale factor here by 2, that means I'm multiplying my x values by 2 and my y values by 2. So my new E, my E prime, is going to be negative 8 comma 4. My new F would be 8 comma 4. My new G would be 6 comma negative 2. And my new H prime, will be negative 6 comma negative 2. Okay, so if I plot those, let's go ahead and get to my E. I have negative 8 comma 4, which would be here. My F would be 8 comma 4, which would be here. G would be 6 comma negative 2, which would be about here. Make sure don't forget your prime notations. And then H would be negative 6, negative 2. So as we can see, this shape is quite a bit larger when we connect all the dots, right? So the algebraic representation here was we multiplied all values of x and y by 2, or 2x comma 2y. Okay, all right, let's go on to the next example. This one we're going to multiply by a scale factor of 3 over 2. So the angles here are not the angles, this is a triangle. We know that this is going to be 1.5 times larger because 3 over 2, if you turn it into a decimal, is 1.5. This is IJK, so let's go put that in order. Side I is 0 comma 4. Okay, side J is 4 negative 2. Side K is negative 4 comma negative 2. Okay, and then we're going to apply a scale factor of 3 over 2, sorry. So 4 times 3 over 2 would look like this. 4 over 1 multiplied by 3 over 2 would reduce to, or would become 12 over 2, which equals 6. Okay, so we know 0 times 3 over 2 is 0. So our new I prime, would be 0 comma 6. Okay, so we already have 4 here, so we're going to do the same thing. J prime would be 6 comma, now we need to do negative 2 times 3 over 2. So negative 2 over 1 times 3 over 2 is equal to negative 6 over 2. Okay, and negative 6 over 2 results in negative 3. Okay? If we do the same thing over here for k prime, well, we've already done 4. We just needed to add a negative. So negative 4 times 3 over 2 will be negative 6. And negative 2 times 3 over 2 would be negative 3. Okay? So let's go ahead and graph those points. Let me make that look a little neater for you. So if I graph that, it's going to look like this. So we have 0, 6, which is my new I. I have 6, negative 3, which would be my new J. And then negative 6, negative 3, which would be my new K. If I connect those dots here, we should see, and it's not going to be perfectly straight, and that's okay. But we should be able to see our much larger triangle. Okay, now the algebraic representation here, we're going to write this as this improper fraction. That's going to be 3 over 2 times x and 3 over 2 times y. We can leave it like this. If you felt the need to turn it into 1.5, that's fine as well. But improper fraction is perfectly acceptable for dilations. Okay, so moving on. And we're almost done with this lesson, so if this is making sense, great. If not, remember, you can always pause and rewind. If you're still not getting it, send me a message, ask to come to tutorials or advisory, okay? So find the scale factor that was used in the dilation. We are on to number 6 now. So remember, the new is the one with the prime notation, so I'm going to go ahead and label that new, which means that this guy right here is my old. So then how do I go from new to old? Remember, to find scale factor is new over original. What I'm going to do is I'm going to pick one point to make this work. You can pick any point, but I'm going to pick one. So in this case, I'm going to pick m. So my new m prime, is 5, 5. And I'm going to put that over my old m, which is 4, 4. If I look at these numbers, I can see that my ratio is 5 over 4. And I can leave it like that. And you can notice it's both the same on both of these. So my scale factor is 5 over 4. Now, to show you that this works with any other side, I can use L, and L prime is 5, 10. Okay, and original L is 4, 8. Now, if you look here at these ratios, I have 5 over 4, and then I also have 10 over 8. Both of those are proportional. 10 over 8 reduces to 5 over 4. So even if I were to say 10 over 8, if I simplified it to 5 over 4, this would still be my scale factor. So notice, you can pick any point on the triangle or your image or pre-image and still be able to find your scale factor, as long as they correspond with one another. Okay, so let's try another one. Let's do All right, so on to number 7. Let's look at this one. Remember, the new has the prime notation or the little apostrophe. Remember, it's called prime notation though. So the new is the smaller one, right? So that's my new, which means that this bigger triangle is my old or my original. So I'm going to work smarter here, and I'm going to use point P because the numbers are smaller, and that means I don't have to work as hard. So I have new over original, which would tell me P prime over P. So P prime is 1 or 0, 1, and original P is 0, 3. Well, I can't find scale factor from 0, but I can find scale factor from 1 over 3. That's already reduced, so my scale factor is 1 over 3. Okay, if you needed to use another point to verify, we could use Q. Let's write over here. Let's say I have Q prime, which would be 1, 2. And then we could put that over the original Q. Oh, let's undo that. And that would make that 3, 6. So if we look there, we can see that 1 over 3 is my scale factor, but also 2 over 6 reduces to 1 over 3. So once again, just a reminder, you can use any point on your figure to find scale factor as long as they correspond and we reduce. So we're always going to simplify our fractions as much as possible, okay? All right, last 3 and then we are done with this lesson. So we need to find the scale factor that was used to dilate each of these points, and we're going to go 8 through 10 just to show you this is only one point on a figure. Once again, it's new over original, so if we're looking at this, the new is the one with the mark, so that's my new, and this was my old. So we would set this up as either 6 over 9. In fact, I'll write both of them just so you can see. We have 6, 8 over 9, 12. Okay, so normally we would say 6 over 9 would be my scale factor, but we need to reduce this to lowest terms. So lowest terms would make this 2 over 3, because if I divide 6 by 2, right, let's go ahead and write that down here. If I divide 6 by 3, right, divide by 3, this becomes 2 over 3. If I divide 8 by 4, right, this becomes 2 over 3. So they both have the same scale factor. They both reduce to 2 over 3. So my scale factor for number 8 is 2 over 3. Okay? Let's try another one. Let's look at number 9. We're going to do new over original again. So we have new over original. And in this case, we have t prime over t, which would say 12 over 10. Okay, so I only need to pick one point because as you see here on this first example here, right, this point and this point reduce to the same thing. So I only need to work with one coordinate. So I'm going to choose the x coordinate this time. And 12 over 10 reduces to 5. Oh, that's not correct. If I divide these both by 2, this reduces to 6 over 5. And then we would leave it there. Okay. If you wanted to verify, negative 18 over negative 15 would also reduce to 6 over 5. Okay, so now look at number 10. Same thing, new over original. What would happen if I were to do 0 over 0? Well, 0 over 0 will not give me a scale factor because you can't figure out anything with 0, but I can look at the x values here, which would be negative 9 over negative 1. Okay, negative 9 over negative 1 would reduce to a positive 9. Okay, remember negative divided by a negative is a positive. Okay, and that would be my scale factor there. All right, so just to recap, scale factor is when the ratio of the new over the original, when we reduce that, that tells me what factor I multiplied by to get my new shape. Okay. Scale factor is always shown as multiplication. So when we look at our algebraic rule, once again, this is 3 over 2 times x, 3 over 2 times y, 2 times x, 2 times y. Scale factor is always multiplication. When in doubt, draw a table like this table here where you have your pre-image and image or new over original. Okay, draw a table so you can see visually what's going on, and then last but not least, always simplify. Okay, so hopefully this lesson helped you. If you have any questions, send a message, pause, rewatch the video over again if you need to. But until next time, all right, take care, guys. Bye.